For still 2017 exam paper. Question 2 now. Okay, before question 2, we left one part, question 1, C part 3. Find the complex numbers Z is equal to X plus IY, where X, Y are real numbers, for which Z minus I is equal to 2Z minus 4I. Now being given that Z is X plus IY, so 2X plus IY. This means that inside here you can write as X plus I factored out, 1 minus 1. Outside as 2X plus I factored out, 2Y minus 4. And then get this guy. This guy is the square root of X squared plus Y minus 1 squared, which is equal to 2X plus 2I Y minus 2. Then we want to square, so even this side will square, so that we have X squared plus Y minus 1 squared is equal to 4X squared plus this guy times this guy, will get 4, then 2 of them, so we'll have 8x Y minus 2I, and then 2I times 2I is negative 4. Without I, Y minus 2 squared. Then now we expand, so have X squared plus Y squared minus 2Y plus 1 is equal to 4X squared plus 8XYI minus 2X, minus 2 times 8, that's 16. So that is 16XI minus 4Y squared plus Y squared minus 4Y plus 4. So this guy and this guy, it gives us negative 3X squared. Or maybe we'll take this other side so that the negatives can be avoided. So taking this to the right, we have 3X squared. And then we're going to deal with this. And then we'll leave the other ones is equal to, it will go as negative Y squared plus 2Y. Yeah. To avoid confusions, we've only picked X squared, taken the other side. So Y squared has remained here, minus 2Y plus 1 is equal to, here we have 3X squared now, plus 8XYI minus 16XI minus 4Y squared plus 16Y minus 16. Then this Y squared taken the other side, the Y's would increase. So we're going to have 3X squared minus 5y squared. This negative 2y taken to 16y, we're going to have plus 18y. And then 1 taken to that guy, we're going to have negative 17. And then plus 8xyi minus 16i is equal to 0. Now, for it to be equal to 0, we require that the real parts be equal to 0 and the imaginary part be equal to 0. So the imaginary part is 8xy minus 16. This is 0, implying that 8xy is equal to 16. Divide by 8, divide by 8, we'll get xy is equal to 2. So from there, we can choose to solve for one of the variables, say y is equal to 2 over x, and then bring it in the equation 3x squared minus 5. There we have 2 over x squared plus 18, 2 over x minus 17 is equal to 0. Which says that this is 3x squared minus, that's 4 by 20. By 5 we get 20 over x squared plus 36 over x minus 17 is 0. Oh, for sure. Then multiply throughout by x squared. We're going to have 3x4 minus 20 plus 36x minus 17x squared is equal to 0. That has become a very serious polynomial. 3x4 minus 17x squared plus 36x minus 20 is equal to 0. So for x, so you look for zeros that will satisfy this. So let's see. If we use 1, then we're going to have 3 minus 17 plus 36 minus 20. This is not 0. If we use negative 1, we're going to have 3 minus 17 minus 36 minus 20. This is not 0. That was 3 minus 17 plus 36 minus 20. It's not 0. So we use 2. So if we use 2, we'll use 3. Let's use 3. So we have 3 power 4 is 81. 81 by 3. 243 minus 3 squared is 9. 9 by 17. 153 plus 86 by 3. 108 minus 20. Yeah, it is not 0. We use negative 3. This is to be 243. This is to be negative 153, and this would be negative 108, and then minus 20. So let's see, 243 minus 153 minus 108 minus print. Yeah. Okay. So I don't know which one will give us 0. Otherwise, we only have the relationship of the two.
Sir,
Hello.
excuse me. So can we solve it like using the definition of modulus, where we first solve it with positive, then the other one we solve it using negative. The one in modulus, then we equate to the left-hand side.
Modulus of a complex number is not. The modulus of a complex number is not the positive thing. Is it? Look at this. If z is equal to 2 plus 3i, its modulus is 2 squared plus 3 squared, which is 4 plus 9. It's the root of 13. That is what it means. So if we define it that way, okay, but I don't know. I wanted to give an example now. You can't even figure out an example. So if we say this is the same as z minus I is 2z minus 4i, or z minus I is negative 2z plus 4i. Not for complex numbers. Not for complex numbers. This is the this was the way. Except that I think there was some something is not right. This polynomial here. This polynomial here is not easy to solve. Okay, so you should try to solve this polynomial. If somebody finds the solution for this polynomial, then let us know in the group. Then we'll carry on to the solution. But we don't spend our whole time here. Question 2, A1. Find the domain and range of the function. Find the domain and range of g of x is equal to 2 plus the root of 33 minus x means sketch. So the domain, we just go for the inside. X is a real number such that 33 minus x is greater or equal to 0, meaning that x is a real number such that x is less or equal to 33. because 33 minus x is greater or equal to 0. When you take it to the other side, you're going to have negative x is greater or equal to negative 33. Then divide by negative 1. Then you reverse because of the negative division. In the range, since you have said that this guy should be greater or equal to 0, it will always feed you back with greater or equal to 0 thing. So the minimum you can get is 2 all the way up to infinity. So at the sketch, you got the domain. If you place 33 there where there is x, g of 33 will be 2 plus 0, which is 2. So you get 2. And when x is 0, you get 2 plus root 33. So this graph goes this way, and this is 2 plus root 33. And you're done. I hope these things haven't left your head. Part 2, if f is 3 x plus 4 and g is 1 minus x over 3. Solve f of g inverse of x. Is equal to it didn't finish the equal to sign. So just put is equal to 2. Form an equation. The idea is you find this f of g. So f of g is you go to f and put g where there's x. So you have 3 g plus 4, which is equal to 3. G is 1 minus x over 3 plus 4 over 1. So we have 1 minus x plus 12, which is 13 minus x. Then you say, so that, oh, this is g of, this is g of f, this is f of g. Now we need to find the inverse, so we let it be y, have 13 minus x, and then switch them. So the inverse is just itself. It's just 13 minus x. Then now you say, then 13 minus x is going to be equal to 2. So that you get negative x is equal to 2 minus 13. So you're dealing with x is equal to 2 minus 13 is minus 11. Divide by negative 1, divide by negative 1. So x is equal to 11. Be more interested in this step. 3. I'll find the inverse. If you have y,
No, just for x.
exactly. You take this side and take this side. So you have x is equal to 13 minus 1.
Oh.
Okay, so another one, sketch f of x is equal to x minus 9 over x minus 4. Indicate all asymptotes and intercepts. Asymptotes, we have what we call vertical asymptotes. Vertical asymptotes. What do? We equate the denominator to 0. Let x is equal to 4. So right there, sketching out an asymptote. X is equal to 4. Then if it's equal, or you just get the limit as x goes to infinity of the function. We are now looking for the horizontal asymptotes. Since we have done calculus, life has become very, very easy. So to find the horizontal asymptote, you get the limit as x goes to infinity. And this is going to be, how do you get the limit? You factor out the highest degree of the denominator. So you have this, and so this will cancel, so you get 1. So 1 is horizontal asymptote. And then the first thing you do is you now look for numbers. This is 4, remember? So a number bigger than 4, like 5, you want to check whether it's above or below that. So 5 will be 5 minus 9 over 5 minus 4. This is negative 4. So 5 against negative 4 down here. So it means that this guy actually will cross the x-axis. This shouldn't put me under pressure. This point I can remove it now. I've known the position where that thing is going to be, so that I sketch the function free. So it's coming like this. But because it has touched that guy, I thought you must know all the intercepts. So you get this into 0. It's got that is 9. Because when you equate x minus 9 over x minus 4 to 0, you get x minus 9 is equal to 0. So x is equal to 9. And then the sum that we do also, if there's a variable in the numerator, we equate the whole function to the horizontal asymptote and see if it's possible. But in this case, it's not possible. So we are safe because negative 9 is not equal to negative 4. So we've known that this graph won't touch the asymptote. So you come to the other region, you can pick 0 there so that can know the y-intercept. If you pick 0, you get negative, you get f of 0 is negative 9 over negative 4, which is 9 over 4. 9 over 4 is 2 point something, is bigger than 1, so this is 1. So the graph is going to be up here. So you sketch it this way. So we are done. That's how the sketch looks like.
Sir,
Mm.
we have a question on that, on this part. What if the value of x, which is a denominator, has high degree compared to the numerator? How can we find the horizontal asymptote?
The horizontal asymptote is a limit as x goes to infinity of x squared minus 1 over x3 plus 4x. How do we find the limit? You say the limit as x goes to infinity. You go for the highest degree in the denominator, have it factored out, get 4 over x squared. Go with it in the numerator, you get 1 over x minus 1 over x3. So that this is x3. So that this guy cancels, we remain in the limit as x goes to infinity, 1 over x minus 1 over x3 over 1 minus 4 over x squared. This is 0. This is 0 over 1 minus 0. So we have 0 over 1, which is 0. So the intersection will be 0.
All right, thank you.
So this question paper is very packed. So we end here. The class is 11:20, guys. At 19:30. So we've just done question 1 and 2A. It's 2B and 2C. Said by Mr. Uncle. So you will see by the time we finish this paper that there was much to be done and you need to be more serious on preparing for the exam. This is not, you can't be slow here, you can't get any if you are slow. You need to be fast. Okay, we'll continue tomorrow.